Well, we should now consider even and odd functions. And so functions that are symmetric with respect to the x-axis are called even functions. And we have an algebraic test for that. And that is that the f of negative x, the function of negative x, is equal to f of x. This would give us an even function. Now, before we take a look at the odd functions, if we have a graph that is symmetric with respect to the x-axis, actually that's not even a function. That's just a graph of a relation. Now, odd functions. Odd functions are symmetric with respect to the origin. In other words, we can rotate that 180 degrees and the graph would appear to be the same. But our algebraic test for that is that the f of negative x is equal to the negative of f of x. So we're going to take a look at a few of these and do some tests, whether they are even or odd functions, or in some cases, neither even or odd functions, using the algebraic test. So in our first example here, we've got f of x is equal to 2 divided by x squared. So now remember, if it is an even function, then f of x is equal to f of negative x. So let's test this first. Let's say then we're looking at the function of negative x. Is this going to equal 2 over x squared? Well, let's see here. So I would have the 2, that doesn't change. And then I've got negative x squared. Well, negative x squared is just going to equal x squared. In other words, if I had 2, if I substituted 2 for x squared, well, 2x squared, 2 squared is 4, and negative 2 squared is 4. And so f of x then would equal 2 of x squared, which is equal to f of x. And so this is an even function. All right, let's look at this. G of x is equal to 4 times the square root of x. Well, let's see, what would happen if we've got g of negative x? Well, that would then be 4 times the square root of negative x, but we can't take the square root of negative x. That would violate one of our 2 cardinal rules. Now, what about an odd function? Well, an odd function is saying that f of negative x is equal to the negative of f of x. Well, I can't even get past this first part right here, because f of negative, or g of negative x in this case, I can't do. I'm trying to take the square root of a negative number. So therefore, this is neither even or odd. And then we're going to look at the last one. What do we got here? H of x is equal to x to the 5th minus 2x cubed plus x. Well, let's first start with h of negative x. Let's see, then that would give us negative x to the 5th minus 2 times negative x cubed plus negative x. But when I solve that, negative x to the 5th, if I raise anything to an odd power, it's going to become negative. So that'd be negative x to the 5th. And negative x cubed would also give me a negative number, which then is going to give me, when I multiply that times negative 2, that's going to become plus 2x cubed, 2 negatives, and minus x. Well, that's what f of negative x would be, or h of negative x. Well, what about this if I do negative h of x. That would be like distributing -1 to that whole original function. And if I did that, then that's -x to the 5th plus 2x cubed minus x, distributing a -1. Well, that equals h of -x. And so this is an odd function. All right, it is so much fun. Test for even and odd function algebraically.